Good morning and welcome to the HL7 Open Source Tooling Series. Today, we welcome Nikolai Ryzhikov, who is the Chief Technology Officer for Health Samurai, part of the FHIR Management Group, and an integral part of the FHIR community. He's going to share with you the FHIR Schema preview. So welcome, Nikolai.
Thank you. Thank you, Sandy. So thank you for having me. Hi, everybody. And let's start. Yeah, so let me check that I can switch the slides. So this is kind of unusual talk. So this is not like well-established open source project. This is just a preview of the new project, but I think it is very important because I'm personally believe in this project, and I will try to convince you why. So a few words about me. I'm CTO of Health Samurai and a passionate member of FHIR community almost since the beginning. I did a few contributions like Firebase, FHIRPass, especially I worked on FHIRPass.js initial implementation, SQL on FHIR, and now FHIR Schema is coming. So I promised it for the year, so now we close to that. So what is a FHIR Schema? And it's going to be the community spec and a few reference implementations. So it is heavily influenced by JSON schema design. And essentially, this is another representation of FHIR structure definition. But this representation designed to simplify the validator implementation. And we're going to provide very clear and detailed algorithm specifications. So everybody who wants to implement FHIR validation will be able to do that. The specification will come with a JavaScript reference implementation. We found this is a very nice combination. For example, we did this in our SQL on FHIR and in FHIRPass. So it is good when the specification coming with some implementation as well, which is extremely important and should go with a very comprehensive test suite. And so again, we did similar stuff in SQL on FHIR because the implementers need this test suite to be sure they conform it. Why FHIR Schema? Yes, so the FHIR, we all understand that FHIR profiling is very important, but we have a problem. Yeah, we have an elephant in the room. So we only have like 1.5 validator implementations. So for example, we have grams, Java and A.C sharp implementation, and that's all. So no other well-known implementation. For example, we don't have JavaScript Python implementation. Why? Why this? Because only like 2.5 people know how to implement FHIR validation. And that's something wrong. And yeah, well, here's a joke that only one guy understands how the snapshot generation is working. So something wrong with that. And the FHIR Schema is going to solve this problem, like demystifying the FHIR validation. So again, what the current project status? It is a very beginning, it is a preview, but we already implemented this in our commercial FHIR backend, 8-box, and we run it for 1.5 years in production. So it is not completely new, it's battle tested. So we wrote the draft spec. So we did experiment with the JavaScript implementation, and that's nice. So we were able to implement the half of it in a week. So I hope that we will prove that it is easy to implement FHIR Schema. And we started working on the test suite, and we like it. So, and I'm pretty sure that it will become big. Okay, so what are the promises, features, and use cases for the FHIR Schema? So what the key idea of the FHIR Schema versus structure definition? So structure definition is a list of element with the paths and IDs. But the FHIR Schema doing in a JSON schema like it is recursive data structure. Another key aspect, it is snapshot-less validation. So we don't use snapshots because I consider snapshots anti-pattern. I will have another slide about snapshots. And we will talk about this. And what another very important aspect, so it is a unit test. We need good test suite to force implementation, and that's not the case with the current FHIR validation. We have only a few integration tests by gram, and they are too complicated to start your implementation. So as well, we want to do like integration with FHIR shorthands. And the FHIR schema may work for code generation and other use cases like code generation or metadata lookups like auto-completion and like FHIR resource editors or FHIR paths. And we did this in a few projects. So it really works very nice. But this is kind of like side effects. Okay, a few words about the snapshot. So for me, snapshot, so the FHIR validation algorithm essentially split between snapshot generation and validator. Let's make it complicated. So the snapshot, again, it's my opinion, it is implementation detail. It is like storing Uber jars in Maven, yeah, so, and I consider it anti-pattern because it's like double size of all the packages. You're forced to rebuild your packages if you depend on something and this something changed, so it doesn't allow us to do the modular stuff. Again, so it's like publishing Uber jar in Maven. And yeah. And for FHIR schema, the snapshot is just a merge operation. So, and it's a part of the algorithm. Okay, so how FHIR schema look like? So it looks like JSON schema, but with the FHIR data types, not JSON data types, and different keywords. So for example, instead of properties, we're using elements because the FHIR semantic is slightly different. It's hard to describe with a JSON schema. To be honest, before, like a few years before, we tried to translate FHIR structure definition to JSON schemas. But this attempt failed because like JSON schema becoming like quite ugly. And the JSON schema, like, yes, so there's like mismatch between these two. So we decided to use like core idea of JSON schema, like the validation is a set of keywords. Each keyword is a rule, and so and the schema is recursive, but just create FHIR specific keywords. So let's say we're using meta framework of JSON schema. We are not using JSON schema keywords, but we're introducing specific FHIR keywords. Like elements will handle like this undifferentiated like collection and singular elements stuff, the underscore primitive extensions. So yeah, as well we're adding like binding keywords and so on. So here are another examples how in FHIR schema we can like express different aspects of validation. Like we have required, this is almost borrowed from JSON schema. We have constraints, this is coming from FHIR. We have binding, which is very similar to FHIR, and extensions. Okay, so why it works? Why we think that FHIR schema will be much more easier to implement and straightforward than implementing like structure definition interpreter? Because the schema shape is a shape of like follow the shape of the data. That means that your algorithm can walk through the data and through the schema and execute like keywords, like rules on every node. So the general shape of algorithm is quite straightforward. So you're just walking through the data and you're walking through the schema. And because they are isomorphic, so you're just walking these two structures at the same time. And on every node, you just validate the rules by schema. As well, instead of snapshot validation, we may keep multiple schemas in a context, and we may walk multiple schemas at the same time. And so that's why we don't need snapshots. So we even tested with hundreds of schemas, so like profiles. So you can run at the same time like a resource against hundreds of profiles. And there is no duplicating parts because we don't have a snapshots. We don't have a repeating rules. Yes, for some complicated cases, we use like I call it collaborative validation, when like every rule creates specific context, put additional information, and then on the post hook it is validated, for example, with the reslicing or stuff like this. So this is a part of the algorithm. Okay, so when we like apply this idea that the schema shape should be like the shape of the data, so the general algorithm becoming as easy like this. This is pseudocode, but okay, so we're walking every schema in the context, and we're walking keywords in the schema, and we validate keywords against the data. And then if the data is an object, so we're walking key value and recursively drop down into the same function. That's all. So that's the core of the validation, that the function you want to implement. And it is becoming really straightforward. Okay, let's see. Maybe questions. Okay, let's put the question at the end. I will be fast. So what you have to do to implement the FHIR schema, you just have to implement like about dozen of keywords. It is half of JSON schema implementation, and it should be even easier than JSON schema implementation. And we have like hundreds of JSON schema implementation in open source. That's why we believe that implementing FHIR schema will become straightforward. Maybe even using like frameworks for different languages which implement JSON schema. Just by implementing custom keywords, you will be able to implement the FHIR schema. So there's another very important aspect which is like missed in the FHIR specification. It's a kind of different story, but it is very important. So that's how canonical resources resolution should work and the packages. So there is a lot of talks, and especially in CRMI community, like working group. So what are packages and what are canonical resources, how they depend on each other? But there's a very simple analogy which we may use. If we think that the packages is like libraries in Java or modules in Node.js, and the canonicals are just class names. So if we think that way, so these two concepts like canonicals and packages, they are orthogonal to each other. And it is good because, yeah, so when you're resolving, let's say, canonical by URL between your packages. And the packages are like library, and you may use like Java style resolution where the class pass, and when you're trying to load the class, so the virtual machine class loader start looking from the top of the list into the like jars. Does this jar have a class? If it has, it's returned and cached. So for example, it can be done this way. The Node.js module resolution works slightly different. It allows you to have like multiple versions of the same library. But what I'm pretty sure that the FHIR specification probably needs this canonical resolution algorithm to be stated clearly. And for example, in our library, we just implemented the, let's say, abstract interface canonical resolver, and we implemented very naive, but you may implement like Java-like resolver or Node.js-like resolver. And it's a part of this project, and I think it's going to be a good contribution into like the FHIR ecosystem as well, because not only validator require this canonical resolution specification. And it is very important that not all packages are like perfect. There are some mistakes, errors, and we have to have ability to monkey patch. Let's say the package may have like broken profile, and I should be able to somehow override this broken profile. And using Java style, so I can put like library like jar before with my version of the profile, and that way I can monkey patching. So, but I think we should discuss in the community how we could monkey patch, but I think this is, again, so the core idea that we can think like Java class loader and jars and apply the same stuff for the FHIR, and it's going to be quite valuable. Okay, so the test case. This is a very important for me aspect. So I bring this to FHIR PassJS implementation. I brought this to the SQL on FHIR implementation because I had a very nice experience implementing JSON schema. So there's an official test suite for JSON schema where the tests are represented as a files, the JSON objects. They do provide like schemas, data to validate, and the results. And when I were implementing JSON schema, I spent like less than a month, and I was passing test by test, and it was very like nice DDD driven implementation of some standard. And I really love it. But when I come to the FHIR, we don't have such a unit test to like implement validator. And it's hard to do. But for the FHIR schema, I'm pretty sure we would be able to create such a small unit test cases, which only cover specific aspects of the validation, and the implementers can focus on this specific aspect, pass the test, and then go further. So we start doing these test cases. I'm pretty sure this is probably the main value of FHIR schema will be these test cases, or at least the half of it. Okay, so we started reference implementation in JavaScript, and we just implemented maybe half, but we implemented the essential part of it, and it is really small. So if you go to this reference implementation, it's just like 500 lines of code. It depends only on the FHIR path. It follows the algorithm which I showed you. So, and you can read it in 20 minutes. You can load it into ChatGPT or Claude and ask to explain it to you. So it is really straightforward. This is not the final version. I think the final version will be even much more clear than this. So, but again, so that's, for me, it is important that we can like have a very small and very clear code which express the algorithm. So implementers may go look at this and implement by themselves. So, okay, so let's get back to the slides. Okay, yes, so for the FHIR, so there's a converter between structure definition and the FHIR schema. So, and we like pre-packaged all the FHIR public packages, converting everything to FHIR schema, like structure definitions to FHIR schema, and representing it as a ND.json files. And this is a very nice source of metadata for code generation, for validation, for, I don't know, auto-completion. For example, this is like US core, which is only like a few kilobytes. And so we published this into S3 bucket. And so, yeah, you can just, and we're keeping it up to date, like scraping the packages and converting to FHIR and representing packages as ND.json files. So if you need like run validation or code generation, you can easily grab this like simplified version of the package. Or you may use like npm packages, but it's much slower and bigger than you may expect. So, and this part gonna be this like simplified packaging for FHIR schema with the converter gonna be the part of this project. So the general idea that it should be very easy to load the packages, resolve dependencies and stuff like this. Okay. So what the roadmap? So yeah, we definitely want to add more test cases, and we want to make it test driven. So we will make JavaScript implementation as good as possible. So after that, we're gonna pass Graham's integration tests. So we pass it with our internal implementation in 8box, but we're gonna pass it with a reference implementation. At that moment, this FHIR schema validator will become like officially valid. So we want to add some extra stuff like FHIR schema sandbox, so you can play online with that stuff. And I will show you sandbox, which is run using our internal engine after this slides. So we want to publish and keep up to date FHIR schema registry repository to easily download packages and conversions, so you don't have it convert on fly. And we definitely will publish our structure definition converter to FHIR schema, and we should develop like probably the back converter from FHIR schema to structure definition. And what's like nearest nice fruit we can give, we can take. So this is like fish integration, because internally fish is more similar to FHIR schema than to structure definition. And now when you like compiling fish into structure definition, then you have to run the snapshot builder and then run validator. With the FHIR schema, you would be able to run like the the validation in milliseconds, because you don't need snapshots. The transpiling is going to be like a few milliseconds, and then you can run the validation.
Thanks for sharing and you all participating. Thanks for watching. If you found this helpful, give us a like, subscribe, and hit the bell so you won't miss the next one.